So I'm gonna delete this one. But you see how it would go, right? And then I'm gonna start another rung. Then here, then here. Then I'll put two outputs over here. Okay. So you can assign symbols before you even start your program, if you know what you want to call it. So I could come over here and you can change it if you screw up, and this happens all the time. You come over here and you pull the wrong instruction down and you give it a name. You says, oh, that's supposed to be an unlatch. Then you can literally delete symbols and add them in this chart here. So it's all the way on the left-hand side in your project tree right here. So I could come up here and I could add a new record, and then I can say input, colon, 0/0, and then I can call it whatever I want to. So I'm going to call it sensor 1. Okay. And then I could add another record, input, colon, 0/1, and then I'll call it sensor 2. And if you make a mistake, you can come in here and correct it. So if the book tells you what symbol to use and you misspell it, you can come into this table and just click on the sensor, and you can change that. So I hit enter. I'm gonna add another record. Input colon 0/2. I'm gonna just call this sensor 3. And a lot of programmers do this. They actually set up their symbols before they even start programming. And then you're dealing with names, and you're not dealing with numbers anymore, which is good. Of course, I just made a mistake. Input colon 0/3. Then I'll call this sensor 4. Or I can do it on the fly. So now I can come over here now, and I can just go up here, and I can type. And as soon as I start typing, it pops up any symbol that starts off with those characters. And now, huh? Oh, you mean the symbols? Yeah. Where you can do symbols? All the way down at the bottom. So if you scroll down at the bottom of your project tree under database, it's called address and symbols. So if you assign the wrong symbol, and you get down here and you says, oh, this symbol's supposed to be assigned to this guy, well, you can just go in there and reassign it. So it's a really neat feature. So look, now I'm dealing what? So there's sensor 1, here's sensor 2, here's sensor 3. Oh, I'm sorry. Sensor 1, sensor. Yeah, here's sensor 3. And then here's sensor 4. So now I'm dealing with what? Names instead of addresses. And if you take PLC 3, you're definitely going to do that. And what's nice is that we're transposing or taking programs that was written for Allen Bradley, and they've got all the symbols in there for you. So once you do that, once you set up your symbol chart, you can look at the Allen Bradley thing and draw the circuit and just type in we're gonna set up a symbols table first to just determine what input on the Siemens corresponds to the input on the Allen Bradley, because they address it. Or you can do it this way. So I can come over here and I can say B3 colon 0/0. So we can assign it on the fly. There's a 0. And of course, what I can do, so if I come up here and accidentally click it away from it, and I said, oh my goodness, I got to assign that sucker a symbol, because that's required in this class. Well, you could come over here and do it here, okay? Or you could come over here and right click on this and do what? Edit symbol, and then we can give it a name. So you can assign symbols several different ways. Now I'm using a B3 file. What is that? Huh? No. You're dealing with the other class. So. Yeah. Huh? It's what we call an internal core. So this PLC's only got 6 outputs. And I'm going to use this core for one thing. I don't want to turn something on. I'm going to use it to make a decision inside my program. So instead of sacrificing one of my outputs that's not going to turn on the light, it's not going to energize a solenoid, it's not going to start a motor, it's not going to do anything, the contacts are always going to be in my program, then we'll use what we call an internal file. Every PLC has it. This calls them B3s. 5,000 or, I don't know why they call it B10. It would only be a B10 if you added a B10. Do you see a B10 over here? You see bit 3. But if I wanted a B10, I could come up here and write on this, and I could say new, and I could come up here and assign this to 10. And now all of a sudden I say, okay, now I got a B10 file. But I don't know why the book talks about B3 and B10, not unless it's for the SLC 500 that they're dealing with. But I don't want that, so what can I do? I can just right click on it and choose delete. So here we're going to use B3. We're not going to run out. B3, we got 256 words worth of B3. And they're bits. So that would be 256 times 16. That's how many B3, that's how many bits that would be available in that B3 file. But if I run out of that, how many would that be? 256 times 16. Anybody doing that? A lot, right? But if I run out of that, I could do what? I could add another B3 file. Or I might want to do this. I might dedicate one B3 file to something, and then another B3 file to something else. So let's go. I'm going to call this latch B3, and this is going to be 0/1. If you want to call it that, you can call it B353 if you wanted to. So this is not determined by, the B3 files is not determined by the actual inputs that you have on the computer. I mean, the outputs you have on your PLC. So we got a ton of them out there. And we'll call this unlatch.
To explain this, the one question would be, why are we using B rather than just a simple output?
Because I would just sacrifice my output when I'm not going to use this coil, this simulated coil, to turn on a light. I'm not using this to turn on a relay. I'm not using this to do this. It's all the contacts controlled by that coil is going to be inside my program.
Okay, so if we're using a simulation, we're using something in reality.
If you're using something that needs to be connected to an output and do something, then you're going to use one of your outputs. If you're going to put a coil in your program that is never going to generate an output, then you're going to use one of these B3s.
Why would we use a coil that's never going to generate an output?
Because and that's a good question. Because in a major control logic, 90% of the relays are in there to make decisions. They don't turn on outputs. They don't do anything. They just make decisions. And then when it comes to, I think I showed y'all the programs that's running the Festo line, right? Well, let me show you. Let me show you how many B3 files they use just to make decisions on when things are not make them happen, just to determine how they happen, right? Does that make sense? So 90% we call in motor controls, we call them control relays. So normally in a control circuit, we have two sections. We have a control circuit, and then we have a power circuit. 90% of the relays don't do anything with power. All they're in there is to make decisions, right? But eventually we're gonna get, huh?
What's an example of a decision that one of these
Well, I'm doing it right here. So I'm making the decision. So I'm coming up here in my diagram and I say, okay, if this one and this one is closed, then if sensor 1 and sensor 2 is true, I'm making the decision. Now I could have done it down here, but I'm giving you an example, right? So down here, what I could do is I can use latch. So this guy is going. I'm finally through with all my decisions, all my ands, all my ors, and all this other kind of stuff. And then down here, I come over here and I say, okay, over here I'm going to use an output. I'm through with my decisions. I'm going to do an output. I'm through with my control, so I'm going to generate an output. So here I want to turn on something. And that's the wrong thing. That's not what I want to use. Let me delete this. Oh no, I didn't have to do that. Let's see if I can do this. So if you know those little mnemonics for the instructions, you can. So I changed that to an output latch. So down here, so originally it was an output enable. So down here I'm going to put output unlatch, and now it's going to change over. I'll do that in a minute. It changed over to the one thing that we'll use them for in here is what we call internal relay. These are guys that don't need to turn on the light. They don't need to energize a solenoid. They don't need to turn on the compressor. They don't need to communicate with the outside world. They're just in there to make decisions. And like I said, in motor controls, we call them control relays because all their contacts are in the control circuit. None of them are in the power circuit. They're in the control circuit. They're just in there to make decisions.
Okay, when you say decision, give me an example.
If this sensor and this sensor and this sensor or that sensor and this sensor and this sensor is true, then do this. But if it's not true, then do this. And if it is true, do this. And those are just decisions. And when it gets to all those decisions up in here, when it gets through with all that the decisions generate an output. Okay. So these are actually true programs that are running the Festo line over here. Oh, these are our programs. So program control PLC3 Festo line. Then I'm gonna go to PLC programs, Micrologic programs. It's the wrong way. And then these are the actual programs that run the line. So this is the distribution or testing, which is the second section. And we're going to go down to auto. And so they're making the decision when this side goes this way, when this guy goes this way, and you could actually go over there and see it run. But all these up here, so here's B3 file. So we're in a section called auto. So right here I have three B3 files. Some of them unlatched, some of them latched because it's in the. So this is making decisions. It don't need to generate an output, it just makes to make a decision. These are all B3 files in another rung making decisions. This is all B3 files in this rung making decisions. They're all.
I'm looking at the step of how it's making. Okay.
So this guy is latching this B31. Then it's unlatching it. It's through with that sequence. It's in the next step, so it wants to unlatch this. So let's say we're dealing with a double acting cylinder. We got to energize this cylinder to move it that way. And then when it hits the limit switch, we might want to automatically do what? Swing it back. So what we would do is the first time we'd latch it would cause it to swing this way, and when that sensor triggers, we'd automatically do what? Bring it back. Okay, that's just one example that I could think of. In understanding the logic, all I'm trying to do is say, this is what we do with three files. Three files don't need to generate output. all they're doing is they're in the program to make what? And like I said, in motor control, you're going to learn they're called control relays. So a control relay does not have any contact in the power line. They don't turn on them. They don't reverse them over. They just make decisions on when it's going to happen, right? In big diagrams, 90% of the relays are in there just to make decisions. And that's what a PLC replaces. It replaces all the decisions. And then, but we do it with internal relays. So I showed y'all, I think I showed y'all a picture of a relay cabinet, and then they put a PLC in it. Now, of course, I need to show y'all Lee's out there at the cement plant. Yeah, like I said. So look, B3s, latch, unlatch, latch, unlatch, because it's set in a sequence. Latch, unlatch. So you're going to run into these all over the place. Latch, unlatch, latch, unlatch, latch, unlatch. And then finally down here somewhere at the very bottom, we're going to start seeing true outputs. So I'm in run 30 right now. Now here's the output. So finally it says, oh, okay, if this is true, if all these decisions have been made, if this or this come true with all that garbage up there, then it's going to energize output 0/0. And that's going to be connected to a light, or it's going to be connected to a relay, or it's going to be connected to something else that actually needs to do work outside the program. So all these relays in here, and this is what we're saying. Now, if I wired this up, then 90% of them would be in there just to make what? Just to make decisions. But eventually we're going to generate an output. Right? Huh? What's that? It could. It depends on what decisions you need to make. I think there's a timer in here. But it's decided, and timers don't generate outputs either. They're on a PLC program. But we could use the timer to generate an output, right? A certain amount of time. I think there's a timer. So there's a timer. There's an on-the-way timer. What it does, it generates a done. And then what we do is we use that done. But that would be an internal coil too. And then we can use it as our decision. So there's a timer. That's an on-delay. Set up for 3 seconds. And we'll get into timers, later on. So this is what I'm trying to show you, and that's why I deliberately put B3 files in here so you'll get a feel of what they're worth. So this guy right here, when this is true and this is true, this guy makes a decision, okay, it's time to turn on an output. And then so I come down here and put that here. But what I'm doing is I'm doing what we call a latch and an unlatch. So it says there's no syntax error. And like I said, just because it passed that test doesn't mean it's right. It just means it's in the right syntax, right? You understand? It's just like you wrote a book about cars and then the first sentence says something about a boat. Well, if it's written correctly and it's spelled correctly and the punctuation's correctly, then it would be the right syntax, even though it has nothing to do with cars. So if I came over here and I duplicated output, without latch and unlatch, it wouldn't give me an error because it's in the right syntax. So what do I do now? I got my program ready. I don't have any errors. I know I can download it. Does it mean it's going to work? No, I don't mean it's going to work. So let's download it. So it does we got it on remote. So we come over here and we just download it. And when we download it, it'll ask us do we want to switch online, right? And okay, but let me get off let me go back. So right here, if you want to give the PLC a name, you can come over here to processor properties. And then right here, there's your processor name. And so I could call this Rich. I could call it anything I wanted to. So from now on, this PLC would have a what? A name. So now when I go to comms and it shows me all the PLCs that are active, if you give them all the name, now I can select the PLC and now I'll be programming that. By the way, you could change the PLC. It can recompile it over to a different PLC. So right now we got it set up for the 1100. But if I wanted to take this and download it onto the Micrologic 1000s, then I could come in and change it over here. I could change my communication standards. So right now we're doing 485. But if I wanted to change it over, if I hooked up Ethernet and I wanted to change it over to that, I could actually change it over to Ethernet if I have the driver installed in RSN. So that's where we can give the processor a name. So now when I create a program, it'll come up and get with that name, right? Okay, so, did I download it? No, I got out of it. So now, this is really strange because this is where it, well, even Microsoft Word, you give it the name at the end. If you don't give it a name, then it chooses something out of the first sentence right up there. Y'all ever did that? And then you can change the name if you just type it in. So even on Microsoft Word and Microsoft Excel, those, you don't give it the name until you get ready to save it. But most of your other PLC applications, so we'll call this latch. This is where we would change where we wanted to put it at. Oh my goodness. Okay. So it says it's not available. We call remote mode. So we can switch it between its other two modes with our computer, right? And what's the three modes the PLC can be in? Program, run, and remote, right? What's the two modes our application can be in? Offline and online. So right now I'm going online with it. So you could literally, and I talked offline, you can create programs. You can select a CPU, you can create your whole program from your house. You can come on, hook it up to the PLC. So if I had to have this sucker hooked up all the time, I'd be in trouble, right? Once I switch this thing and run, you can take that cable out. I mean, it's gonna just sit there and run the program forever, right? You understand that? So of course, gonna switch it into run mode when I get through. So we got it in remote. Then it's gonna ask me, do I want to go online? So now it's gonna switch my application. Oh, it's gonna go online on it. So this is my program. It's up here running. Of course, when it starts if it's running, you should see the little ladder doing what? Spinning. Okay, so what do I have to do to generate an output? Sensor 1, sensor 2, and the output latches. I'm going to come up here and make it false, and notice this output over here stays true because it's latched, which is really neat because now we can latch something and we can come back later and do what? Unlatch it. So now I can flip the switch. Now I want to unlatch it. I can come over here and now I got an OR. So I can do 2 and it unlatches. Right? Let's place it back. By the way, look. So that would be something that would cause a problem. Well, we're latching. As soon as we unlatch, we're doing what? The latch rung is still true. So you don't want to do that. That could cause a problem. So I'll have to make the latch. And what you find out is this, they both have the same symbol because they're the same core. It's just that one of them's used for latch, one of them used for unlatch. We have, if we was over in the motor controls lab, we have a latch and relay over there. We had them out at US Steel we had a lot of radio controlled cranes over there where the guys run these big old 40-ton cranes from a little transmitter they wore on their belly.
Now, the PLC
I'm using it right here.
Well, I'm saying, like, in the reality of it, if you have a program system now, why would you use the relay?
Excuse me?
The new technology of PLC.
You still have memory, you still have cores, so all of them have cores. Every PLC that you'll program supports ladder language. 90% of the program is going to be decision making. We don't want to sacrifice an output for a relay core that's only in there to make a decision. Okay? So every one of them supports what we call internal relays. Internal relays, you do not sacrifice an output that does nothing. You understand what I'm saying? So if I've got a core that's in there to make a decision and it does not have to turn on the light, it does not have to turn on the motor, it does not have to turn on the solenoid, it does not have to communicate with the outside world, then I'm going to use an internal core. In any PLC, the 1500s, the 314Cs, the compact logic, all of them support internal cores. These are cores that don't do anything to the outside world. They just make decisions when it finally goes to the outside. Until we make all the decisions that we need to make, then eventually it's going to generate an output. I mean, it doesn't make any sense to. Until it's necessary. Well, it's not wasting it. So when we finally made all our decisions, when that motor turns on, right, then we'll have to use an output because the motor's out here. But 90%, guys, that's a lot. So think, and that's PLCs, that's what they save. They save those internal cores. That's where it saves those relays. So when we look at a cabinet, we showed y'all it's got 500 relays in there. And then I show you it's got 4 relays that turn on motors, and all those other relays are gone. Well, all those other relays, those are what we call control relays. They're not in the circuit to turn on a motor. They're just in there to make decisions. Does that make sense? And like I said, I say 90% of my wiring, because if you got a control relay, you got to do what? You got to wire it with wire, and then you hook up the sensors to that. So this is just a little bit of example. And every PLC that you see is going to have memory cores. In fact, Siemens calls them M. We call them M cores, because they're strictly in the memory of the computer. They're not in the outside world. And that's one of the things I told y'all. When Ars Logic 500 came out, the primary people programming PLCs was electricians. They didn't understand memory. They understood ladder diagrams. They understood control relays. They picked up real fast on the B3 files, right? Because they said, I've only got 15 outputs, and here I've used 15 of them that don't do anything to the outside world. But they didn't know how to manage the memory in the computer. They had no idea what RAM was, ROM was, what drivers were. But now, the new PLCs, you manage the memory. What they did here is it manages the memory. So if we look at the project tree on 5000, you will not see data files. You will not see data files. And when you create an input, that's when you're going to use it, right? You understand that? That makes sense. So do y'all understand control of what we call internal cores now, right? So in fact, on that diagram, the latch and unlatch was done by B3. But it was making all those decisions before it got down to the bottom. And if you look at that station, it's only got like 4 actuators on it, right? But it's got to make the decision when things happen. So if I was going to, and do we still have control? If every rung in my program, every rung has to generate an output, we're not going to use a PLC. I mean, if they do, they're crazy. Because you could wire it up, right, and save you a ton of money. But if you got to make all these decisions and to get rid of all those control relays, so that's what the PLC does. It doesn't get rid of the power relays. It gets rid of the what? The control relays. So I could use the output to pick up a contactor. In fact, we could look at the Amatro line and you see they got motors out there, but the PLC, so the big PLC can't run the motor, but the PLC can pick up a power relay that runs the motor. But then we got all the decisions going. So this is latch and unlatch. So this is the only time you should ever duplicate a latch. So the book says never, they're not. So every single job building has these Stephen called them said and same thing. So we okay. And we're doing a little logic up there. We have an and at the top, only two contacts. So that's something you got to understand, that and is a minimum of two, right? But you could have a ton down that string, and ors are a minimum of two. You have 3 and 4. Well, no, 2 and 4, 2 and 3. Remember, we start running. They start numbing from 0. Yeah, so this is, as soon as we switch to the online monitor mode, this guy does it automatically. And they don't show you the entire power flow. They just show you what contacts are actually closed. All they do is just put the green around them. So notice when I turn switch 0 off, it lost its 2 green sides. So that means that's false. And the signal is not getting through that contact. So I'm listening. Mm-hmm. Those are actually outputs. Those are true. They start with those. So look, you can look at my PLC. See that light on right there? So that means that output's lag. I'm gonna come over here and flip switch 2, and it's unlatched. So the light goes off. Up here, I got to turn this one and this one to make decisions. And now we latch. But as soon as I do that, I can make I can make rung. So rung 0 and rung 1 are both false. But the output is still on because it's what? We duplicate. So for every latch instruction you have, somewhere you better have a what? Unlatch. Assign the same symbol. You can't give them different symbols, and they're going to be, because that's the tag assigned to that, and they're going to have the same address. And they'll both be energized at the same time, or they'll both be off on. So as I come over and I switch 2, then now we unlatch. And notice both of them are off. But we're doing this with one core. And like I said, we had these things on our radio controlled cranes, because every once in a while we'd say the operator would lose a reset because it's radio, right? Understand that? It's just like if you get too far out of range. Well, that sucker's got a big old electromagnet down there that's got a bunch of steel on it, and it loses the reset, right? And then the magnet turns off. And it drops all the stuff and kills a bunch of people. Well, they used a latching relay on that. So they would latch it, so even if they lost the reset, they kept power on the wad. They kept power on the magnet. Until they did what? Until they unlatched. So we got one of those. It had 2 coils on it. So you actually had 2 coils. One of them you would energize to cause it to latch, and then you could turn that off, and it would stay what? It would stay latched until we unlatched it. So that's the only place I remember them being out there on every radio control crane that we had. We had that latching relay on the magnet circuit. So right now I've got I'm So what we're going to look at now that we didn't cover in detail is something called forcing. Forcing. Forcing is when you can energize output and simulate into it. They still call it forcing without having anything connected. So I'm going to come up here. So notice my force is what? Can y'all see it right here? Enable. Then we have a table down here called force files. So I'm going to come here and click on my inputs, and it brings up my input data file. Well, right now I've got all watts in there. Dots, right? So what I'm going to do is I'm going to come over to my keyboard, and I'm going to type in a 1, and I'm going to hit enter. And we should have saw this output, this input, go true. It says red though, because it's been what? Forced. Am I touching my switches? No. Then I can come over here and I can break up my input file, and I can go over to the next dot and I can put a 1 there, and then, okay, and then of course output 0. Am I hitting any switches? No. To get rid of it, you just highlight it and then you hit the delete key. Okay. So I hit the delete key, and it should go back to a dot, guys, if I didn't mess up, yeah. Hit the delete, highlight it, hit the delete key, and delete, yeah, there we go. And I'm gonna highlight it and hit the delete key, and hit enter. And then it goes back to dots, and notice my two outputs, my two inputs went false. We can also bring up our output table, and it does the same thing. So here's output 0, and you can do this anywhere down the table. And I'm going to come over here, and I'm going to force output 0. So I just double click on it, and my left mouse button, I hit 1, hit enter. Okay. Am I in the output? Oh, output 1 is already, output 0 is already, oh. It doesn't show me, it didn't pop up, but it's on. Huh? Oh, I'm sorry, I was up here on my big 3 file. Yeah, so we forced it on. Thank you, Jen. And that's the only output that we're using. And I'm going to come over here and click on the output again. And then what I do to get rid of it, I double click on it, hit delete, and then hit enter, and it should turn off. It did turn off, but we latched it, right? So, what's the problem with using this? So it's great for troubleshooting. So what would be the problem with doing this? Well, see, and all those sensors are usually in there, and that's the safety of the system, is the sensors, right? So in a robot, is the gate closed? Is the gate open? Somebody can get in there. Well, you get in there and force that sensor, and then the robot takes off and starts moving and kills somebody, right? So I'm not saying don't use the force, but what I'm use the force. The force is I know, it did not. It's okay to use the force, or the force capabilities. That's not an instruction, but you better be sure of what you're doing, and don't just use it in an active system, in a system. So I can use it here all day long. But who am I going to kill? Nobody, right? So you could do this. You could have your PLC. You could have your PLC, and you could bring up a PLC in your shop, and you could test it to see if these sensors were, if you trigger these sensors, is your program going to work right? Right? You understand that? So you could test it like that. When you get it get out there and get that thing out there in the system and you force that, you could just have done what? Kill somebody, you know. So be really careful, and I think I told you, I think I showed y'all, and some of y'all's been back there at the line. Just about all your power relays, you have the ability to manually override them or force them. I mean, I think, did I tell you about the guy up in number 8 Glassburn, where they forced a relay and cut him in two? So he simply pushed the wrong relay. So, and they didn't lock it out. And so whose fault was it? It was the guy's fault that was up there, because he should have locked out everything inside that section he was working. But forcing is neat. Like I said, it's really neat. If I'm writing all these programs and I'm doing all this and it's not out there on the line yet, right? You understand? And I want to see if my logic is right. If this sensor energizes, this one energizes, and this one energizes, and this one energizes, is output 0 going to come on without even having my wire? And then I take my PLC out and wire it into my system. If I wire it right, we shouldn't have any problem. I've seen that happen too, where they hook up the wires wrong, and that's not good too. So that's forcing, guys. So there's, the latch and unlatch, that's a very powerful, instructions. And like I said, we could duplicate that with this sealing circuit that I showed y'all, right? But I'm doing all that stuff when I could do it with one relay. So they use that set, and like I said, Siemens calls them set and reset. Siemens calls their internal coils, they call them M coils, which makes sense to me because that's memory coils. And we call them B3. But we're going to be using the B3 files. If you take PLC2, we'll be using, no, we won't. Because PLC2, we're going to be moving over to the Compact Logic if you take that class. Okay, so let's see what labs we can do.